determine if number 12 THHN wire can be used to feed a 15 horsepower, 460 volts, three-phase motor, we need to follow a few steps. The motor has a full load amperage of 21 amps and the instantaneous trip circuit breaker is set to trip at no more than 168 amps, with lugs rated at 90 degrees Celsius. The motor also has proper overload heaters installed. Firstly, we calculate the motor's running current. The formula for current is power divided by voltage. Power in this case is 15 horsepower, which we need to convert to watts using the conversion factor of 746 watts per horsepower. So, 15 horsepower times 746 watts per horsepower equals 11,190 watts. The voltage is 460 volts, and since it's a three-phase system, we also need to account for the square root of 3, which is approximately 1.732. Therefore, the calculation becomes 11,190 watts divided by the square root of 3 times 460 volts. This equals 11,190 watts divided by 796.72 volts, resulting in a running current of approximately 14.5 amps. The problem states the full load amperage is 21 amps, and since the calculated value of 14.5 amps is less than the full load amperage of 21 amps, we can assume the motor runs at its full load amperage. Secondly, we select the appropriate wire size based on the running current, referring to the National Electrical Code, NEC, Table 310.15. B16. This table provides the ampacity of insulated conductors rated for not more than 60 degrees Celsius through 90 degrees Celsius in free air. According to this table, number 12 THHN copper wire is rated for 25 amps at 90 degrees Celsius. Since the motor's full load amperage is 21 amps, which is less than the number 12 THHN wire's ampacity of 25 amps, number 12 THHN is suitable for this application. Thirdly, we need to check the circuit breaker rating. The instantaneous trip circuit breaker is set to trip at 168 amps. This value is greater than the motor's full load amperage of 21 amps. An instantaneous trip breaker is designed to trip very quickly in response to a high fault current. Its purpose is to protect the circuit and equipment from damage due to short circuits or ground faults. The breaker's trip setting should be high enough to allow the motor to start without nuisance tripping, but low enough to provide adequate protection against faults. In this case, the breaker is set at 168 amps, which is 8 times the full load amperage of the motor 21 amps. This falls within the typical range for instantaneous trip circuit breakers used for motor protection, as they are often set between 7 to 10 times the motor's full load amperage to allow for the inrush current during motor starting. Given the breaker setting is 168 amps, which is greater than both the motor's full load amperage and the calculated running current, the circuit breaker is properly sized for the motor. Fourthly, we check the circuit breaker lug rating. The circuit breaker lugs are rated for 90 degrees Celsius, which matches the temperature rating of the number 12 THHN wire. When connecting conductors to equipment, it's essential to ensure that the temperature rating of the conductor is compatible with the temperature rating of the equipment terminals or lugs. This is to prevent overheating and potential failure of the connection. The NEC typically requires that conductors be selected and installed so that their temperature rating matches or exceeds the lowest temperature rating of any connected termination, conductor, or device. In this scenario, the lugs are rated for 90 degrees Celsius, and the number 12 THHN wire is also rated for 90 degrees Celsius. Therefore, the connection is compliant with the NEC, and the lugs are appropriately rated for the wire being used. In conclusion, based on the given information, number 12 THHN can be used to feed this 15 horsepower, 460 volts, three-phase motor, provided that the motor has proper overload heaters installed. The circuit breaker and its lugs are both appropriately rated for the motor and the wire size. It is important to note that while the calculations and code references provided here are based on generally accepted practices and the NEC local codes and regulations may vary, It is always recommended to consult with a qualified electrician or electrical engineer to ensure that all electrical installations comply with the applicable codes and standards in your specific area. This ensures the safety and proper functioning of the electrical system. Overload heaters are crucial components in a motor control circuit designed to protect the motor from overheating due to excessive current draw over an extended period. They function by monitoring the current flowing to the motor and tripping the control circuit if the current exceeds a predetermined level, thereby preventing damage to the motor windings. Overload heaters are typically selected based on the motor's full load amperage and are available in various types, including thermal and electronic versions. Proper selection and installation of overload heaters are essential for ensuring the longevity and reliability of the motor. When selecting a wire size for a motor circuit, several factors must be considered to ensure compliance with the NEC and to provide adequate protection for the motor and the electrical system. Firstly, the wire must have sufficient capacity to carry the motor's full load amperage without overheating. Secondly, the wire must be properly sized to minimize voltage drop, which can affect the motor's performance and efficiency. Thirdly, the wire insulation must be suitable for the environmental conditions in which it will be installed, such as temperature, moisture, and exposure to chemicals. The NEC provides tables and guidelines for selecting the appropriate wire size based on these factors. It is important to consult these resources and to follow the recommendations provided to ensure a safe and reliable installation. Circuit breakers play a vital role in protecting electrical circuits and equipment from overcurrents and short circuits. They function by automatically interrupting the flow of current when a fault condition is detected. Circuit breakers are available in various types, including thermal magnetic, instantaneous trip, and electronic trip. Thermal magnetic circuit breakers use a combination of thermal and magnetic elements to provide overload and short circuit protection, while instantaneous trip circuit breakers provide very rapid protection against high fault currents. Electronic trip circuit breakers offer more advanced features such as adjustable trip settings and diagnostic capabilities. The selection of the appropriate circuit breaker for a particular application depends on factors such as the circuit voltage, current rating, and the type of load being protected. It is important to choose a circuit breaker that is properly sized and rated to provide adequate protection for the electrical system. When working with electrical systems, it is essential to follow safe work practices to prevent electrical shock and other hazards. Firstly, always to energize the circuit before working on it. Secondly, use appropriate personal protective equipment, such as insulated gloves and safety glasses. Thirdly, follow lockout/tagout procedures to ensure that the circuit remains energized while work is being performed. Fourthly, inspect all tools and equipment before use to ensure that they are in good working condition. Fifthly, never work alone and always have a qualified person nearby who can provide assistance if needed. By following these safe work practices, you can minimize the risk of electrical accidents and ensure a safe working environment. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association, NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important for electricians, electrical engineers, and other professionals involved in electrical work to be familiar with the NEC and to follow its requirements to ensure the safety and proper functioning of electrical systems. The NEC is not a law itself, but it is often adopted by state and local governments as the basis for their electrical codes. Therefore, compliance with the NEC is essential for meeting legal requirements and ensuring the safety of electrical installations. The temperature rating of electrical conductors and equipment is an important factor to consider when designing and installing electrical systems. The temperature rating indicates the maximum temperature at which the conductor or equipment can safely operate without degrading its performance or lifespan. Conductors and equipment are typically rated for 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. The temperature rating of the conductor must be compatible with the temperature rating of the equipment terminals or lugs to which it is connected. The NEC specifies requirements for selecting conductors and equipment with appropriate temperature ratings to ensure safe and reliable operation. Voltage drop is the reduction in voltage that occurs along a conductor due to the conductor's impedance and the current flowing through it. Excessive voltage drop can cause problems with electrical equipment, such as reduced motor performance, flickering lights, and inaccurate readings from electronic devices. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to select conductors with sufficient size and low impedance. Calculations can be performed to determine the voltage drop in a circuit and to select the appropriate conductor size to meet the NEC recommendations. Grounding is an essential safety measure in electrical systems. It provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and de-energize the circuit. Grounding also helps to minimize the risk of electric shock by providing a reference point for voltage. The NEC specifies requirements for grounding electrical systems to ensure safety and proper functioning. These requirements include the use of grounding electrodes, grounding conductors, and bonding jumpers. Proper grounding is essential for protecting people and equipment from electrical hazards. Overcurrent protection is another important safety measure in electrical systems. It protects conductors and equipment from damage caused by excessive current flow due to overloads or short circuits. Overcurrent protection is typically provided by circuit breakers or fuses. Circuit breakers are automatic switches that trip and interrupt the flow of current when an overcurrent condition is detected, while fuses are devices that melt and break the circuit when an overcurrent condition is detected. The NEC specifies requirements for selecting and installing overcurrent protective devices to ensure adequate protection for electrical systems. These requirements include the use of overcurrent protective devices with appropriate ampacity and interrupting ratings. Electrical enclosures are used to protect electrical equipment from environmental conditions such as moisture, dust, and corrosion. They also provide a barrier to prevent accidental contact with energized parts. Electrical enclosures are available in various types, including metal, plastic, and fiberglass. The NEC specifies requirements for selecting and installing electrical enclosures to ensure adequate protection for electrical equipment. These requirements include the use of enclosures with appropriate NEMA ratings for the intended environment. Electrical conduit is used to protect and route electrical conductors. It provides a physical barrier to protect the conductors from damage and also helps to contain any arcs or sparks that may occur in the event of a fault. Electrical conduit is available in various types, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The NEC specifies requirements for selecting and installing electrical conduit to ensure adequate protection for electrical conductors. These requirements include the use of conduit with appropriate size and material for the intended application. Wiring methods refer to the techniques and materials used to install electrical conductors. The NEC specifies requirements for various wiring methods, including wiring in conduit, cable wiring, and open wiring. The choice of wiring method depends on factors such as the type of building, the environment, and the type of load being served. The NEC provides detailed guidelines for each wiring method to ensure safe and reliable installations. Electrical drawings, also known as electrical schematics or wiring diagrams, are used to represent the electrical system of a building or facility. They show the location of electrical equipment, the wiring connections, and the control circuits. Electrical drawings are essential for planning, installing, and maintaining electrical systems. They also provide a valuable reference for troubleshooting electrical problems. Electrical contractors, engineers, and electricians all use electrical drawings to understand and work on electrical systems. Electrical safety is of paramount importance when working with electricity. Electricity can be dangerous and can cause serious injury or death if not handled properly. It is essential to follow safe work practices and to use appropriate personal protective equipment when working with electricity. Always de-energize circuits before working on them, and always test to make sure that the circuit is dead before touching any wires or equipment. Never work alone, and always have a qualified person nearby who can provide assistance if needed. By following these safety precautions, you can minimize the risk of electrical accidents and ensure a safe working environment. The 460-volt system mentioned is a common voltage level for three-phase power distribution in commercial and industrial facilities in North America. It is derived from a 480-volt system, where 480 volts is the phase-to-phase voltage. When a neutral conductor is present, the phase-to-neutral voltage is approximately 277 volts. The 460-volt system is used to power a variety of equipment, including motors, pumps, and HVAC systems. It is generally more efficient than lower voltage systems for transmitting power over long distances. The choice of voltage level depends on factors such as the size of the facility, the type of equipment being served, and the local utility standards. Understanding the characteristics of the 460-volt system is essential for designing and installing electrical systems in commercial and industrial buildings. A three-phase motor is an electric motor that operates on three-phase alternating current power. Three-phase motors are commonly used in industrial applications due to their high efficiency, reliability, and power density. They are typically smaller and lighter than single-phase motors of the same horsepower rating. Three-phase motors have three sets of windings that are spaced 120 electrical degrees apart, which creates a rotating magnetic field that drives the motor. The speed of a three-phase motor is determined by the frequency of the power supply and the number of poles in the motor. Three-phase motors are available in a wide range of sizes and configurations to meet the needs of various applications. Horsepower, often abbreviated as HP, is a unit of power commonly used to measure the output of motors and engines. 1 horsepower is defined as the amount of work required to lift 550 pounds 1 foot in 1 second, or approximately 746 watts. The horsepower rating of a motor indicates the amount of mechanical power that the motor can deliver. The higher the horsepower rating, the more powerful the motor. Horsepower is an important factor to consider when selecting a motor for a particular application. The full load amperage flaw of a motor is the amount of current that the motor draws when operating at its rated horsepower and voltage. The full load amperage is typically listed on the motor's nameplate. The FLA is an important parameter to consider when selecting conductors, overcurrent protective devices, and other components for a motor circuit. The conductor's ampacity must be equal to or greater than the motor's FLA to prevent overheating. The overcurrent protective device must also be sized appropriately to protect the motor from overloads and short circuits. The National Electrical Code (NEC) is a set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association, NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a law itself, but it is often adopted by state and local governments as the basis for their electrical codes. Therefore, compliance with the NEC is essential for meeting legal requirements and ensuring the safety of electrical installations. THHN is a type of insulated electrical conductor commonly used in building wiring. THHN stands for thermoplastic high heat resistant nylon coated. THHN conductors are insulated with a layer of thermoplastic material that is resistant to heat and moisture. They are also coated with a layer of nylon for added protection against abrasion and chemicals. THHN conductors are typically used for wiring in conduit or other raceways. They are available in a wide range of sizes and colors. The temperature rating of THHN conductors is typically 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations.